guys, welcome back to my channel. So today we'll be solving the DNA counting problem, and it is available in the Rosalind's website. The links will be given in the description box below, so make sure to check that out. Now before getting started, let's see a little bit about a DNA nucleotide. Now in this problem we'll be dealing with some of the nucleobases like A, T, C and G. A, T, C and G is found in the DNA, and A, U, C and G is found in RNA. Now, just to give you a hint, the next problem that we'll be solving is based on this. Now, A, T, C and G stands for A, which is adenine, G, which is guanine, C, which is cytosine, and T, that is thymine. Now let's not go deep into this and let's get started with the program. Now the first thing that we will look is the question. Now what will be given that a DNA string of length at most 1000 nucleotide, but for a sample data set I'll be using this one to check whether it is correct or not. And it will return 4 integers separated by spaces, counting the respective number of times that the symbol A, C, G and T occur in S. Now, there are many methods through which we can solve it, but in this we will check out any 2 of them. The first method will be using strings and the second method will be using dictionaries. Now let's see the first method, that is using strings. And I'll be giving you the data set, the actual data set having the 1000 nucleotide in the description box. Now let's start the first method using strings. So first of all, what I'll do is that I'll make a variable, say NTS, and I'll be using this sample data set. So yeah, so I have taken this as my sample dataset. Now I have to make certain variables which will store the different values of this A, C, G and T. So for A, I'll be take the small a, so A equal to 0. Similarly, we will also initialize the value of the others. So C equals 0, G equals 0 and T equals 0. Now what we have to check that for NT in NTS, there is no hard and fast rule that we have to write for NT in NTS, but it's just the way to check for the element, and we can give any variable over here. So there is no rule of giving the name of the variable, so we can use any variable. Now for NT in NTS, if NT is equal to A, then what will happen, that the value of A will increase by 1. This means that A is equal to A plus 1. This is what this particular line signifies, and I'll just copy this one and do the same for the others also. And then it will check for NT equals C, it will be C plus equal to 1. Same for G and same for T. So now what will happen, whenever the value or the value of NT will be A, so it will just increase the value of the small a. Now what I'll do, is that I'll print all these, and when we are printing, we have to make sure that we are printing outside the loop, else it will just increase the value one by one and it will be printed inside the loop only. So I'll print A, C, G, E. Let's run this. So now you can see that it is 20, 12, 17 and 21. So we have got the same sample output. So this program works. Now sometimes what happens that if we just see this one, like in this, the for loop, we are using so many if statement. So the program would be more efficient if we can make it more shorter, and it would be then more efficient, because in this what is happening that the if statement has to work several times. Over here I have 1, 2, 3, 4 times. So the if statement is working 4 times. So to just decrease the amount of steps and increase the efficiency, we can use the second method, that is using dictionaries. Okay, now the second method is using dictionaries. So let's see how we can do it. Is I will take a variable nts is equal to, okay, and then I'll use or I'll initiate an empty dictionary. So count is equal to, now what I'll do is that for nt in nts, if not nt in count nt is equal to 1, else count nt plus equals 1. Print count. Now what is happening over here, that for every not in nt, if not nt in count, so I'm just checking if nt is not in count, then count nt is equal to 1 and else, and if nt is in count, so that is the condition, else count nt plus equals 1. So in this what is happening, that the value is getting increased, and finally we are printing the count dictionary, and let's see whether it runs or not. Now yeah, so it did. Now what's the difference between this one and this one is that this is more organized and this is less organized, and the main factor is that this one is more efficient than the method 1. So we can use either of these two, but the more efficient one is this one, and it can be written in a very short steps. So this one is more preferable, and the first dictionaries will be posted soon, and in between we will continue with the evils part, and we will see how we can make a simple stone paper scissor game using the evil statement and another import sort of keyword. And let's see in the next video. Thank you.